Yeah, so we're going to be on the notes page, which is just, there's only got one side to it. The front two examples talk specifically, they ask you for all the details of the parabola, and then we're going to graph it. And then the back side's blank, but we'll probably do two more examples on the back side that go backwards. Instead of asking you all the details about the parabola from an equation, I give you some parameters and you have to go backwards to tell me the equation. All right, so here's how it works. A parabola. Now, you've dealt with parabolas for many years in math. A couple of the main key features that are different from what we're going to be graphing now is definition's the same. Parabola is the set of all points in a plane that are the same distance from a given point, which is going to be a focus. So that's different. We've never, other than in Algebra 2 when you dabbled in this for a hot second, we've never really graphed the focus of a parabola. Additionally, it's the same distance from the focus to a given line, which is called a directrix. Does that word sound familiar at all to any of you? Directrix? Yeah. So it's from last year. You may not remember exactly what it is, but of course that's what I'm about to share with you. This one we are probably a little bit more familiar with. Every parabola has an axis of symmetry, and it's exactly what it sounds like. It's an axis where we can fold our parabola over such that every point matches up to a point on the other side, and it intersects the vertex. So the vertex of a parabola is the point at which it crosses that axis. So we're used to seeing parabolas like in the parent function having the equation y equals x squared. Now, that is still what we are graphing to an extent, except we are, and heck, we can even say, okay, we've done y is equal to x minus h squared plus k. That was kind of a general form that we have dealt with even at the beginning of this year. The difference between this equation, though, and the two that we're about to write, there's going to be another variable in it, and it's not going to be a. So a also controls some stretching or compressing there. But the new variable is going to be p. So for this first one, if our parabola, this looks like a standard parabola, it's flipped upward, this one will have the equation. It starts off similar to the other conics. It's going to be x minus h squared is equal to 4p times y minus k. So it looks a little bit different than the other types of parabola forms that we've dealt with already. As you could probably guess, though, the vertex is still in the same, or still has the same variables with h and k. Now, the main difference between other parabolas that we've graphed before, we've always graphed parabolas that are functions, meaning it was either pointed up or downward, and that was it. As soon as we flip the parabola on its side, in other words, when we take the inverse and we do the plus and the minus square roots, we end up having something that is not a function. It fails the vertical line test. Okay. This standard equation is you're going to switch the x's and the y binomial. So instead of x minus h squared, we just have the y minus k squared term on the left side first, equals 4p times x minus h, where again the vertex is still just hk. Now, other details. So we're not used to graphing other things rather than the curve, the parabola U-shape itself. But now in this section, we're going to add onto our picture a focus point. Now, what do you notice about the focus in this parabola here to the left? Tell me, what do you notice about the focus and the vertex? Are they going to share the same x coordinate or the same y coordinate? They're going to share the x coordinate when they're vertical like this. Very good. So that means our focus is going to start off with the coordinate h, and then to get whatever the different y coordinate is going to be for the focus, it's going to be k plus p. when our orientation is flipped to the side like this, the focus is going to share the same y coordinates. So our new x coordinate will be h plus p, comma k. Axis of symmetry, we said, will always intersect the vertex. Okay, it's also consequently will then intersect the focus as well. So when your parabola opens up like this, our axis of symmetry is going to be a vertical line, goes directly through the vertex. So it will have the equation x is equal to h. When it flips on its side, it's going to be a horizontal line. It's going to share the y coordinates. So its equation will be y equals k. Now, in both of these pictures, the axis of symmetry is the dotted black line. The directrix is the dotted red line. So this is the directrix. And in the other one, it's going to be that vertical line. To get the formula for the directrix for a vertical orientation is going to be y equals k minus p. Now, I want you to notice the directrix and the axis of symmetry are always going to be perpendicular to each other, no matter the orientation. And when our parabola is flipped to the side, our axis of symmetry is horizontal, but our directrix is now vertical. And it's found by the equation x equals h minus p. Okay, so by definition, what we said that a directrix is, or kind of what a parabola is rather, is that every point on the parabola is the same distance away from the focus as it is the directrix. So if you look at the vertex, whatever this distance is to the focus is going to be the same distance to that directrix line. And it works for either one. So even if I maybe pick a random point here, the distance to the focus is going to be the same distance as that point is away from the directrix line. Now, it doesn't actually look like it because I stole this picture from the textbook, which was A, illegal, and B, let me put tick marks to show those are congruent. And the page was not laying flat, so it was it has a curve to it. So the dimensions of this shape are not going to be perfect. But that's just by definition. Every point on the parabola is the same distance away from the focus as it is to the directrix line. Okay. The last thing to note is the easy part, and it's very conceptual, is that our parabola is going to open up if p is positive or p is greater than 0, and it'll open downward if p is negative or less than 0. And as you can probably guess, the other orientation, it's going to open to the right if p is positive, and open to the left if p is negative. So these are all the different key features of parabolas in standard form like this. Okay, now I want you to look at these equations. And I want you to tell me, what do you notice? So let me highlight the standard equations. Comparing these equations to the equations of, let's say, a circle, the hyperbola, the ellipse, what is a major key difference? Or there are a few. What are some key differences that you see in these equations compared to the other conic equations? Sounds like it. I'll ask again. AC's on too. Oh, interesting. What is the difference between, or what are some things that you notice that are different between these equations for a parabola versus our equation for a circle or an ellipse or a hyperbola?
Both variables are squared.
Oh, say that again, Zach?
Both variables are squared.
Very good. And that's the major difference. There are a few different differences. We've never used the variable p before. But the major difference between this one and all the other ones is that parabolas only have one squared term. One squared term. And that's going to be crucial for you being able to tell the difference between the conic sections. So remember, I mentioned there's going to be a section on your test where I'm just going to give you an equation, or I'll give you a few different equations, just say graph it. But I don't tell you, is it a circle, is it an ellipse, is it a parabola? So you're going to have to use some distinguishing features between the equations to figure out what you're even trying to graph. And that's going to be the key for parabolas. Parabolas will only have one squared term. Okay, that's it. So we're going to do a couple of examples with graphs. You're going to first write the equation in standard form, and then you're going to find the focus, the vertex, the directrix, the axis of symmetry before you graph it. Okay, so thing to notice. For number one, I've got y squared equals 8x plus 48. If my y squared term is the only squared term, which direction will this open? If y is the one that is being squared.
Right.
It'll open to the right or to the left depending on p. It probably looks like it'll be to the right because there's nothing negative, so p is probably positive. Now, this is not in standard form. It's close. If you compare this to this green bubble right here to the right, it's not exactly in standard form because on the right-hand side, you have to have this 4p term isolated, and then you have to have x minus h in parentheses like this. So y squared is okay. There's just no k term, so k must be 0. And then on the right-hand side, we'll go ahead and factor out an 8. When we do that, we're left with x plus 6. And then this is as far as we need to go here. So that is our equation in standard form. Now, if you wanted, this is what I want to see, but I also could not argue if you decided to go kind of one step further, because if you notice the standard form has 4p as a coefficient here on the right side. So whatever is in that position is equal to 4p. So if you said that 4p is equal to 8, then that implies that p must equal 2. So if you wanted, I would also accept y squared equals 4 times 2 times x plus 6. I would accept that as a final answer as well. Now, you don't have to do that at all. I think what you've done here is just fine. But you do actually have to find p for the focus and the directrix line. So what is our center point of this parabola? I said center point, but I actually meant vertex. Okay, what are the h and the k values? Opposite. -6, 0. H is always with your x, so they swap sides. So h must be -6. There is no k with the y, so it's -6, 0. Let's go ahead and graph that first. That'll be -6 to the left. So there's our vertex point. The focus is found by doing h. Again, this is y squared term, so I'm getting all my formulas from this right side here. So my focus is going to be h plus p comma k. And this is why I solve for p. I know h, once I find my vertex, I have h and k. So I know h is -6. I solved for p earlier. P's got to be 2. So -6 plus 2, comma, I know k is 0. Means that the focus point, -6 plus 2 is -4, 0. So let's graph that. And I recommend you labeling, you don't necessarily have to label the vertex with V, but I definitely would label the focus with F so that you know the difference between the two. Because here's going to be another big takeaway for today. This goes for any of our conic sections. For any of the conic sections, the focus is inside of the curve. Inside the curve. No matter if we're dealing with an ellipse, obviously it's on the inside, but a hyperbola, the focus is on the inside, and for this parabola, the focus is on the inside, which tells us, that solidifies that this is going to open up to the right. So we have the vertex, we have the focus. The next thing we need to find is the directrix line, so you can just shorthand that, labeling it with D. Again, I'm using the equations to the right, so if I use x is equal to h minus p, then I'm going to have x is equal to, we said h is -6, minus p is 2, then -6 minus 2 is -8. So my directrix line is x equals -8. Now, that's an actual line. That's a vertical line. So at -8, I'm going to have a vertical dotted line. And then the axis of symmetry, you could have even graphed before this if you want. The thing to remember about the axis of symmetry is that it's going to go through both the vertex and the focus. So you could follow, y is equal to k if you want, or you can just use your logic and say, okay, it's got to be perpendicular to that directrix. It's got to go through my vertex and my focus. So it must be right here along the x-axis, which is y is equal to 0. So I need to see those 4 things graphed. The last aspect to your parabola is just estimating your curve. Typically before this, we've always kind of done a table of values. You found either 3 or sometimes 5 coordinates that you knew were for a fact were on your parabola. I'm okay if once you find the focus and the vertex and your 2 lines, you just estimate where the parabola would be like this. Questions so far? Okay. Another one similar to this, number 2. The main difference, though, is that there's a lot more maintenance to be done in the equation before we can start finding the details. Notice in our equation, everything is kind of multiplied out, and it's all to one side. So our goal first is to determine, okay, I've got an x squared term here. Therefore, I want to go ahead and put my x squared term, or my x terms on the left side, and put everything else on the right-hand side. So I've got 2x squared minus 16x, and I'm going to move the other stuff. Negative 12y will be at positive 12y, and then minus 20 on the other side. Okay, from here, what are we probably going to need to do to proceed in order to write this in a standard equation or standard form? Yeah, okay, so after that, even after you do that, Zach. Right, like right now I've got an x squared term and I've got an x term. I can't have both of those. So what am I going to do there? We're going to factor something, yes, but I'm looking more for a phrase. After you factor, what do you got to do? Where you like find a new c and stuff. There it is. Okay, so from here you can, when you realize you have to complete the square, we can only complete the square if we have an a value equal to 1. And right now we don't. So you can either factor out this 2 from both terms, or you could notice that everything is divisible by 2. So you can go ahead and divide your entire equation by 2 right now if you want as well. That'll probably be the easier thing, get us some small numbers. So let's do that. If we divide everything by 2, then we end up with x squared minus 8x equals 6y minus 10. So that kind of shortens things down a little bit, but now we still have to complete the square. So when we complete the square, Let me save me some space here. I know I'm going to have a new c. And in order to find the new c, I'm going to do b over 2 squared. So that'll be negative 8 over 2 squared, which is negative 4 squared, which is 16. Now, I'm not multiplying by anything else up front, so when I add 16 to the left side, I really am just adding 16 to the right side. When we take the final step and actually complete the square, on the left-hand side, we get x minus 4 squared is equal to 6y. Negative 10 plus 16 is 6. Now, we're almost there. Remember, you can't have, in standard form, you need it to have like this isolated coefficient and then x minus a constant. So you don't want x to have any coefficients itself. So if x has a coefficient, then we want to, or in this case, y, I'm sorry, we want to go ahead and factor that off. So if I do that, I get x minus 4 squared equals, factor out the 6 so that y has a coefficient of 1, and it'll be y plus 1. So this will be the equation in standard form. Once you find that, we'll go ahead and find the 4 different aspects before we graph. The easiest one will be the vertex. What is the vertex of this parabola?
4, negative 1.
4, negative 1. Fabulous. So let's graph that coordinates. And then after the vertex, we'll find the focus. So focus, again, I've got x squared. So I'm following all of these formulas here that are on the left side. So my focus is going to be h comma k plus p. Well, we already know what h and k are because we already know the vertex. So in order to find this, we just need to go figure out what p is. Well, p, this is the mistake people make. They say, oh, 6 is equal to p, because 6 is just that number that's out front. False. 6 is equal to 4p. Whenever you have that coefficient to the binomial, that's going to be 4p. Which implies when you divide both sides by 4, you get 6 over 4, which reduces to 3 halves. So that implies that p is equal to 3 halves. So then when I plug that in for the focus, I know h is 4, k is negative 1, plus p is 3 halves. Now, this is where if you rely too heavily on the graphing calculator to do stuff like this for you, you're going to be in trouble. So you got to make sure you can complete this without the use of a calculator. For some of you, it's cake. Some of you understand fractions really well. For others of you, it makes you want to poke your eyeballs out. If I want to add negative 1 plus 3 halves, I need to have common denominators. Right now, I have negative 1 over 1. So if I want this to have a denominator of 2, I'm going to multiply this by 2 over 2. So if I have negative 2 over 2, then my focus will be 4. Negative 2 over 2 plus 3 over 2 will be a positive 1 over 2. And just kind of estimate where that is, about a half. So it'll be 4, and then our focus will be about right there somewhere. Next is our directrix line. The directrix line is going to be found by the equation y equals k minus p. Well, again, we know what k is, so it's going to be y equals k is negative 1 minus p is 3 halves. Well, again, we need common denominator, so if I multiply negative 1 by 2 over 2, I get negative 2 over 2 minus 3 halves, which will be y equals negative 5 halves. as the directrix. Now, you don't have to do the algebra here if you are comfortable in understanding the definition of a parabola. So let's pretend we didn't just find that equation. After you graph your focus, if this is your vertex, by definition, the focus is the same distance away from the vertex as the vertex is away from the directrix. So if you say, ooh, this is about 1.5 away, then you go 1.5 away here to figure out where your directrix line should be. So you can even find the directrix line without having to do the algebra if you just use your logic of what it would be like on the graph itself. So that's a 1.5 away as well. Then we know our axis of symmetry is going to be perpendicular to that directrix. It's going to go directly through the vertex and the focus. And it's going to have the equation x equals 4. And then to graph your parabola, again, you need these 4 things. You need a focus, you need a vertex, and you need axis of symmetry in the directrix line. After that, you can just go ahead and estimate what your curve will look like through the vertex point. And that's kind of as complicated as it gets. Does anyone have any questions on any step of that? All right. If you're good, go ahead and flip it over to the back for me. There's nothing on the back, but I just want to do a couple of quick examples of how to go backwards. So instead of giving you an equation and asking you to rewrite it and find all the stuff, on the back side, I'm going to give you some aspects, I'll say, of the parabola, and you have to go backwards to find the equation. Okay, so I want you to find the standard of equation of a parabola given that the vertex is 4, 2, and the focus is 4, 17/8. Now, even though I don't ask you to graph it, I think it is important to understand visually what's happening because it's going to dictate which equation you use. For instance, in either of the equations, I need h and k, which I already give you. I give you the vertex. The only other thing you need to find is p. But before I can even figure out where I'm plugging h and k into, I've got to figure out which equation do I have. Am I dealing with the x squared term or am I dealing with the y squared term? So what I would do is just kind of sketch out a little representation of the vertex point and the focus point and figure out what I'm dealing with. My vertex is at 4, 2. So that may be about like right here. There's the vertex point at 4, 2. The focus point is at 4, 17/8. So I'm still going to go to the right 4 from the origin. Can you estimate what is 17/8? Fabulous. So in other words, thank you for echoing that, Zach and Sebastian, for getting the right answer. In other words, it's going to be a little bit over 2. So if this is my focus and my vertex is just below it, then what does that imply? What direction is my parabola opening? We said earlier the focus has to be inside of the parabola or the inside of the curve. So the only way that that happens, perfect. So the only way that that happens is if our focus is on the inside and this opens upward. So if this opens up, then that implies that our that our x is going to be the squared term. So that implies that we have an x squared, and since it opens up, that also must mean that our p must be greater than 0. And that's all we have to find is p. We already know h and k. So we know since we're using the x squared version of the equation, we're going to be using x minus h squared equals 4p times y minus k. And we already know h and k, so we need to go solve for p. Now, what does the focus have to do with p? How do you find the focus?
or it's actually
Okay, so the h obviously is the first term, and then the y is k plus p. Very good. So if that's k plus p, then I can go ahead and decide and set an equation that says, okay, well, 17/8 is k plus p. And then we already know k from the vertex, k is 2. So then if I substitute 17/8 equals, if k is 2 plus p, then I could just subtract to find p. So if I subtract 2 from both sides, then I get 17/8 minus 2 equals p. Okay, again, if I'm going to subtract fractions, technically this is 2 over 1. If I need it to have a denominator of 8, then I will just multiply this number by 8 over 8. So that'll be 17/8 minus 16/8 equals p. 17 minus 16 means that p will just equal 1/8. And that's the only element that I needed. So I'm going to substitute that value for p back into the equation with h and k. So x minus h is 4 squared equals 4 times p is 1/8 times y minus k is 2. And the only thing that I would ask you from here would be to go ahead, you are allowed to simplify 4 times p. So I would just go ahead and write this as x minus 4 squared equals 4 times 1/8 is 1/2 times y minus 2. And you don't want to distribute that 1/2. You want to leave the y minus 2 alone so that it's clear to tell from this standard equation what h and k are just by looking at it. Okay, last example I'm going to do with you. Same directions. I want you to write the standard equation of the parabola, this time given a vertex is at negative 5/8, but the directrix is at x equals negative 21/4. So again, I'm in a position where I have 2/3 of the variables that I need. I give you the vertex, which is h and k, and the only thing you have to go find is p and which equation to plug into. So again, I would sketch out where this point and where the directrix are to get an idea of what I'm dealing with. So my vertex is at negative 5/8, which might be here. And the directrix is at negative 21/4. Can you even just estimate where is negative 21/4? You know, or not even estimate, give me the actual thing. Okay, good. So the main thing is that it's a little bit more to the left than negative 5. So if this is the directrix line, x equals negative 21/4, what does that tell us about our parabola? What direction must it open? Yeah, if it can't hit the directrix, that means it has to open to the right. So if it has to open to the right, that implies that we're dealing with a y squared equation where p, again, has to be positive. Okay, now, that equation with y squared is going to be y minus k squared equals 4p times x minus h. So I have x and h already, or sorry, I have h and k already. So I need to go find p. What does the directrix line have to do with p? Okay, Zach, it cut out a little bit, but I think you said it. If x is equal to h minus p, and you know that x is equal to negative 21/4, then that means these two things are equal. Then that means negative 21/4 must equal h minus p. But again, we already know from the vertex point that h is negative 5. So then we get negative 21 fourths equals negative 5 minus p. And then all we have to do from here is solve for p. So if we add 5 to both sides, again, technically it's 5 over 1. If I want to add these fractions, I want them to have common denominators of 4. So if I multiply 5 by 4 over 4, then I get 20 fourths instead of the number 5. Minus 21 fourths equals negative p. I could see some of you making that mistake and forgetting that that's a negative. 20 minus 21 is negative 1/4 equals negative p, and we knew from over here that p had to be positive. So when you divide both sides by negative 1, then we get p is equal to a positive 1/4. And then we just need to substitute that p and h and k into our equation. So we get y minus k is 8 squared equals 4 times p is 1/4 times x minus h. So that'll be x plus 5. And then the only thing you can do from here would be to go ahead and simplify your 4p. So we get y minus 8 squared equals 4 times 1/4 is just 1, and we don't need to write a coefficient of 1. So we just have y minus 8 squared equals x plus 5. And that would be the equation of that in standard form given this vertex and this directrix.